All right, go ahead and read through this one. If you don't like it at first, that's fine. I certainly didn't. I thought, first of all, explained very poorly, and second of all, I thought these conditions were a bit silly. But the more I worked on this one, the more I liked it, and actually, it's one of my favorites so far that I've come across. So hopefully, you'll have the same change of heart and come around to it like I did. Um, so let's just explain it really quick because they didn't do a very good job. Um, for each element, they basically want you to take it out and multiply all the other elements. So for this first element, 2 times 3 is 6, 6 times 4 is 24, put it here. Next element, 1 times 3 is 3, 3 times 4 is 12, put it here. Next one, 4 times 2 is 8, 8 times 1 is 8, put it there. 4, 2 times 3 is 6, 6 times 1 is 1, put it there. So hopefully that makes a little more sense. And I'm going to first, actually I'm just going to copy paste one that is just a brute force method that solves this without worrying about these conditions. I actually like this one. It's probably satisfactory for almost every case, but yeah, we will walk through one that satisfies these cases after this. But just real quick, if you don't know the map and reduce methods, go ahead and look those up because this won't make a lot of sense. But when you pass the map method 3 arguments, the first one is that method, or sorry, the element that you're dealing with. Second one is its index. The third one is the array that you passed, so nums, the input array. And what we're doing here, we're just making a copy of the whole array. We're saying for that copy, remove, so just pretty much like we did walking through this one, remove that element, splice it out of there. So when we give splice 1, that means take out one item at this index. And then set our product, so for this reduce method, set the product, basically an accumulator, equal to 1, and then multiply 1 by all the other, or so everything in the array. And now that the current index has been removed, the element at that current index, you'll get this. So I like that solution. It is pretty inefficient in terms of big O. It's going to be n times n because you're looping through for every element, but it'd probably work out in most cases, depending on how long your input array is, I guess. But let's walk through another one that does satisfy the conditions, so the note in the follow-up. And basically for this one, what we're gonna do is let's just use their example as our example. Yeah, this solution is actually really easy to understand as well, I think, for having such strict constraints. Basically, we're going to loop through this one backwards. So let's say this is our output. We're going to have an accumulator. We're going to set it equal to 1. And for this last, so we're looping through this input array backwards. We're going to say for this last one, just give this last output index our accumulator. So now that seems a little weird. Actually, let me just code that for you and show you what would happen. And so we're looping through backwards. Let's just do that too right now. If you've never looped through an array backwards, it's kind of fun actually. We want to set that equal to the the last index, I is greater than or equal to 0, because we want to get all the way to 0 so we can get the 0th index, and then decrement I. And we're going to say output I equals accumulator. So just like we did here, we're saying, and notice how I is going to be 3 at first. So now it's a little weird to set the index 3 of an empty array equal to 1. But what JavaScript does for us is it just fills in these previous indexes with null for us, just to prove it to you. Just so we can have this here for later. Let's just do the example. Oh, console log. Oh, whoops, I forgot to return. Yeah, so after this first time through, it's just going to fill up these first 3 indexes with null because we want to change the 4th index. So index 3, like that, to 1 at first. So hopefully that makes sense. And then now we're going to set our accumulator. So after we set this to 1, set our accumulator equal to 4, or multiply 4 by 1. So now our accumulator is 4. We're going to set this next slot equal to 4. And then we're going to multiply these two. So this is 12. Set our next slot equal to 12. And multiply those two. So I already erased it, but it's going to be 24. And set this equal to 24. And then we actually are going to multiply 1 by 24, but fortunately our for loop is going to end, and we won't add 24 again. So first time through, that's what we want. And to do that, all we need to do is just keep accumulating our accumulator. We're going to multiply, so accumulator equals the accumulator times nums. And that'll give us what we want, this part. So let's check that out. It does. And then I'm walking through the next part. Next, we want to go through it forwards. And we want to set our accumulator equal to 1 again. And we want to say, we're basically going to do the same thing. Basically, we want our accumulator times, so our accumulator equals 1. Accumulator multiplied by 24 equals 24. So this time, instead of setting these equal to our accumulator, we're setting these, we're doing the multiply equals. So this equals this times the accumulator. It's the only one subtle difference, just so that, because we don't want to lose these values that we already have. So this times this is 24. So that was that first one. Then we multiply, and then we say, or no, sorry, that wasn't the first one. The first one is now, so we do 1 times 1 is still 1. This is a little confusing. Maybe it would have been a little clearer if this was a different number, but so our accumulator gets set to 1 again. We multiply these two. So our 12 stays 12 because we're multiplying it by 1 again. So accumulator is 1, and then set our accumulator to 3. So multiply these two to get 3. we multiply 3 by this one to get 12. And then our accumulator becomes 20. No, whoops, I botched it. Our accumulator was sorry, let me do that again. Not sure why I went wrong there, but so our accumulator, this is what we started with 1. Multiply these to get 24, then multiply 1 by 1 to again get 1. Multiply these two, stays with 12. Then we multiply this by this to get 2. Now I multiply these two. Yeah, okay, here we go. To get 8. Then we multiply 2 by 4. Or no, 2 by 3, sorry. Yeah, 2 by 3 to get 6. Multiply 6 by 1. I think this is actually more confusing than the code that I'm about to write, but then we multiply 6 by 4, so our accumulator gets set to 24, but then our for loop ends, and we don't end up multiplying the 5th element, or I guess it would be the first one because it would loop back around. But anyway, yeah, for loop ends there, despite changing our accumulator to 24. So I actually think this will be even easier to make sense of than what I just did, but let's use I again. So just standard, looping through. And we're going to say, so we want to actually, rather than setting our accumulator back to 1, actually, yeah, rather than doing that, let's just do 2 different ones. So let's say back accumulator, because that's the one we use when you're going backwards. Let's say forward accumulator. And now let's do, and so this is the only change, like I tried to emphasize a minute ago, is that we're doing multiply equals because we want that output. We want to keep these, the values that we had the first time around after we're done with this part. And then set that. So same thing as this. These are going to have to be changed to the back. And that should do it. Let's see if we get this. Indeed we do. And just to show you some edge cases, like let's say we had 0 involved. If I put a 0 here now, all the rest of them should be 0 because 0 will be multiplied by them. And this one right here, we take the 0 out, it should be the only one with something. Just what we get. Just to show you some other stuff. You should get that. What's kind of nice is that the number of elements in this list has to be greater than 1. So, but still 2 looks a little weird, but notice how we should get those swapped like that. Same thing all the way around. So this one does work for all the edge cases as well. And it does run in O of n time, O of 2n, but we just In big O world, we just drop the 2 and say that it runs. Yeah, we say that 2 is trivial, so we just say it runs in n time. Yeah, and I really like this one. It is fairly easy to make sense of. I hope it made sense. And if not, maybe just run this video again, and it should make sense the second time. But yeah, I really like this solution, and I ended up really liking this problem as well. And I hope this one helped, as always.